The temperature gradient that we found is the temperature gradient that is established when the flux is transported by radiation. However, when the temperature gradient becomes too steep, radiation is not enough to transport all of that flux, and another process kicks in. That process is convection. So convection is essentially a process of dynamical instability. Let's understand that. Let's understand first what is thermal instability. If you are in a situation of stability, any attempt of increasing the amplitude of an oscillation is not going to succeed. You can imagine a situation like this. You have equilibrium. You have a temperature gradient. So this to the core is bluer, hotter, and this to the surface, colder, redder. Imagine that you have a perturbation. This perturbation here is from the hot side into the colder side. So it's hotter than the surroundings, so it's going to expand and rise. But because it is expanding, it cools. Expansion is cooling the blob. As it cools, it sinks because its cooling is getting denser, and then it's going to sink down and going to go back to equilibrium. So you have an oscillation here. A perturbation tries to rise, expands, cools, and sinks back. What is a situation of thermal instability? The thermal instability would happen if that blob rises faster than it can cool down. If it rises faster than it can cool down, it just keeps rising. It's going to travel a great distance before cooling and sinking back. This process is convection. You see that happening in a lava lamp. It is rising. While it rises, it cools. Eventually, then it cools and then sinks back. So to understand this process, let's consider the bubble in the sun.